Hello Internet, welcome to a new episode Blender Precision Modeling. In the past episodes I have shown different ways how to work with Blender as a CAD tool. By default, Blender focuses on a creative and design-oriented work process or workflow that is less based on given dimensions and technical requirements. You can overcome the limitations of Blender using the introduced techniques that I have shown to you during the past episodes. For example, the use of the numerical input, the direct use of global or sometimes local coordinates, the use of the 3D cursor, the measuring functions, as well as the proper application of the Blender object origin. In this episode, we see how we can use Blender modifiers in combination with the already mentioned positioning tools and add-ons. We will use the array modifier, the mirror modifier and also the curve modifier, and follow a non-destructive modeling approach. Using modifiers will also make the overall design workflow a lot easier and faster. Let's have a look into the examples. In this example, I place a bolt object created with a bolt factory add-on onto a gear-like object. We want to position the holes for the bolts onto the path described by the circle points. Beside the bolt object, I need an object of type empty as the reference object for the array modifier. Therefore, I add the empty object to the 3D scene. The reference object can be any 3D object in Blender. In our case, it is an empty object that is placed in the middle of the 3D scene view. Starting from the center of the 3D scene view of Blender, I set the bolt position to the radius of the circle. In the next step, I apply the location of my bolt object using the current position using the key combination Ctrl A. I then apply the rotation and scale factor in the same way. The black circle in the model is for demonstration purpose only. Now I set the origin of the bolt object to the empty object. Using the last step gives you the possibility to work with the reference object position elsewhere in the 3D scene. Add an array modifier to the bolt object. Add your instance count in the array modifier, deselect relative offset and use object offset as shown in the video. Now every offset value between the reference object and the bolt object will be used to calculate the position of the array instances. Blender will use the object origin offset as well as the rotation offset for the calculation of the position and rotation of the array instances. Here you can see how the change of the offset of the bolt origin and the empty origin affects the overall positioning of the array generated instances of the bolt object. If you rotate the reference object, in our case the empty object, The additional instances of the bolt object will rotate also. The additional instances of the bolt object will rotate around the origin. Rotate the empty to a value to position the array instances precisely onto the given circle. You can then proceed and use the Boolean modifier to cut off the bolt holes out of the gear object. Use this technique if you have circular repetition in your model, like the holes in our example. In a very similar way, the mirror modifier can be used. In the example of the video, I used the curve modifier in combination with the cube object to create circular arc sections. In order for the modifiers to work, as for example the curve modifier, care must be taken to ensure that the objects have enough subdivisions or geometry the Blender functions can work with. A simple approach here is to slice the starting object appropriately. Then I use the mirror modifier to create additional copies of the arc sections. You can choose a reference object and select one or more axes to mirror your object. The position of the mirrored instances are related to the offset of the object origin to the origin of the reference object and the distance to the mirror axis. The cutting is done again with the Boolean modifier. This way of working allows a non-destructive modeling, in which the individual processing steps can be adapted at any time. As already mentioned, we can work very precisely with Blender if we know the downsides of the tool. Proper working with the Blender tools is a key technique for the design process and is the basis of a wide variety of Blender functions and Blender design workflows. In the following video, we see a different art of modeling based on a curve object and a profile object. In this example, we use a curve and a profile object in combination with the array and curve modifier. We can use this modeling technique to create objects with a consistent shape across their length. For example, like a picture frame. In my case, it is a router template that I can use in the workshop. Keep in mind, in the same way as in my other videos, my scene settings in Blender are set to the metric measurement system and the 1mm unit. Also in the properties panel and display section, I set the grid size to 1mm, and normally I set the grid itself, the size of the grid, to the size of my 3D printer print bed. We are starting with the default scene and set a cursor to the center of the 3D view. The default cube can be used later. For the time being, we set it to a different layer using the M key. Now we're adding a curve to the scene. To define a path we want our shape object to follow. In edit mode, set the 3D cursor to the first segment point of the curve. In object mode, set the origin to the 3D cursor. Move the curve to the center of the 3D view. Now the first control point is the start of the curve and will be matched with the shape object origin later on. The control points of the curve can be shifted very precisely in the top level view and the orthogonal perspective. For faster modeling, use the numeric input G key, axis and movement distance. Or better, activate the snap to grid function with increment snapping. Make sure you are in the top level view and orthogonal perspective. Using the grid, you can model the path very fast and precisely. Zoom in to use the subgrid level to model with more precision. If you need more control points, just mark the segment in edit mode using the start and end control point and use segment subdivide from curve menu to create a new control point. Using the control point, you can precisely define and position your curve. Use an object to define the shape of your desired profiled object. In our case, I used the cube from the second layer. I set the origin of my shape object and match the position with the origin of the curve object. First I add the array modifier to the shape object and mark the merge attribute to get rid of the inner geometry. And yes, I forgot it. This is a must-have if you want to add more modifiers later on. For example, a Boolean modifier to cut some holes into the final object. Also, if you want to print the outcome on a 3D printer, you can ease the job for the slicing software and prevent slicing errors when you do not have inner geometry, like faces or edges. Afterwards, I set the curve modifier to the shape object. All instances of the shape object will now follow the path of the curve. Modify the shape object to define your profile. After the modeling of the shape object, I set the length of the shape object to 2 mm. To have a smooth result and to define the overall length with more precision. In this episode, I have shown how to use the different modifiers using the techniques introduced during the past episodes of my tutorial. In addition to the basic working methodology, I have shown 3 examples for non-destructive design approach using modifiers. In the next video, we will again explain other aspects of this topic. For example, we will use the custom orientation and also the snapping tools. I will introduce more techniques and workflows that can significantly speed up your modeling process. If you have special requests for content, if you have questions to the models, the design process, the modeling, feel free to ask. Put your question into the comment section and if possible I will answer them. So you can also have a look into the video description. I added some additional details to each of the videos, so maybe you find the one or the other link that's of interest for you. In the next weeks I will add some additional content more related to 3D printing, especially in combination to workshop tasks. For example, how to create router templates. Currently I'm working on a router table with some additional parts that are 3D printed. So if you like, join my channel and you can follow the content in the future. So if this video was helpful for you, I would appreciate if you press the like button. You are also welcome to subscribe to my channel and follow the other videos on 3D modeling and 3D printing to come up in the future. Bye bye Internet, see you next time.